The Ganga and the Brahmaputra rivers pour 1 billion tons of sediment into the delta of the Bay of Bengal every year. What happens to all that sediment, and how does it make it all the way to where we're drilling, 2,000 kilometers south?
Once it leaves the river mouth, it's deposited in one of 3 places. It's either deposited on the seafloor near to the river mouth in really shallow water, about 20 meters of water or so. A part of it is redeposited back on land by tides, and another part of it is deposited at the head of a submarine canyon. There's a canyon like the Grand Canyon. It's a big indention in the seafloor that is basically a funnel. It's a conduit that transports sediments from the near shore to the very deep water and eventually to the Bengal fan. As sediment is deposited at this canyon head, sometimes it gets to be a little too heavy and it will just collapse under its own weight like a landslide. Other times, if you have a trigger, such as a storm or an earthquake, that can also cause sediments at the head of the canyon or along the canyon walls to completely collapse. That material that falls into the canyon then can turn into what we call a turbidity current. And as these currents gain speed as they roll down the floor of the canyon, they pick up material along the way and become this very, very thick current that flows along the seafloor.
As soon as a turbidity current starts to slow down, what happens is that the material settles down. And the coarse material and also the dense particles will settle down first. And the finer the material, the longer it takes for the material to settle. The result of this settling is a deposit, and this deposit is called turbidite. And if you core such a turbidite, this is what you get. We have that here on the table. So this is a section of a core, and this is the turbidite. And you can see nicely the features of the turbidite, which is a sharp base, and then the relative coarse and dense material is concentrated at the base. And then if you move towards the top, the material gets finer and finer until it's very, very fine, and you need a very good microscope for having a look at these particles because you can't see them by eye anymore. Another nice feature is that we have this color lamination here, which is, it's actually several layers, very thin layers of sediment, and we call that parallel lamination. And these kind of structures, together with the grain size of the sediment, so the size of these particles, tells you something about the energy of this turbidity current and also of the flow velocity. And the Bengal fan is the largest submarine fan in the world, and lots of turbidites. This is the main transport mechanism. So we observed, many turbidites.